Hi, this digital training module is designed for PhD and post-PhD level, but the expert researcher will find it useful too. It is a technical module on the thermodynamics of fluid mixtures. We make here a strong reference to natural magmas, but notice that mixtures are all around us. The air we breathe, the water we drink, the food we eat, our same blood. Practically any fluid in nature is a mixture. Therefore, the concepts and methods that you will learn here have direct applications far beyond just magmas. Still, natural magmas offer particularly interesting and difficult cases for the application of the theory of mixtures. In particular, for the extremely wide ranges in pressure, temperature, and composition that they encompass. Such extreme conditions make common ideal simplifications not applicable. Instead, more complete approaches that fall beyond the general name of real, as opposed to ideal thermodynamics, are necessary. That requires a deeper understanding of thermodynamics that this course will provide you while developing a fully real thermodynamic model of multi-component gas-liquid equilibrium in magmas. Before I tell you of the organization of the digital training module, I would like to remind you of the importance of thermodynamics. To do so, let's see what great scientists said about it. Here is Albert Einstein, who, in his autobiographical notes in 1949, wrote, "A theory is more relevant the simpler it is in its premises, the higher number of different things it is able to connect, and the larger extent of applications it is able to guarantee." From the above, it comes the great impression that classical thermodynamics exerted on me. It's the only universal theory that I'm convinced in its fundamental concepts it will be never rebutted. During the Gifford lectures at the University of Edinburgh in 1927, Sir Arthur Eddington announced, "The law that entropy always increases, the second law of thermodynamics, holds, I think, the supreme position among the laws of nature. If someone points out to you that your pet theory of the universe is in disagreement with Maxwell's equations, then so much worse for Maxwell equations. If it is found to be contradicted by observation, well, these experimentalists do bangle things sometimes. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation." And finally, my favorite one from Homer Simpson, upset after his genius daughter, Lisa, had constructed a perpetual motion machine violating the second law of thermodynamics. Here is how this digital training module is organized. There are 3 units, each subdivided in individual lessons, typically 15 to 30 minutes each. Unit 1 illustrates the theoretical foundations of thermodynamics. The first and second laws of thermodynamics is all you need to start this course. If you don't remember them well, don't worry. I will briefly recall them, and from that simple basis, step up after step, the whole theory of mixtures will emerge. The arguments in this unit are entirely general and hold for any kind of natural or synthetic mixture, far beyond magmas. Unit 2 starts to deal directly with the specific problem of multi-component melt-gas equilibrium in silicate systems. Most arguments and equations are still general, but their application requires choices. that makes us enter the domain of modeling. At the end of this section, you will handle the knowledge and skills required to develop thermodynamic modeling yourself at a level of complexity required by your application cases. Finally, Unit 3 deals with practical computations of multi-component gas melt equilibrium in magmas through the code SolveCAD that implements the theoretical and modeling equations from Units 1 and 2. If you are only interested in learning how to use SolveCAD, you can skip the first 2 units and go straight to Unit 3. You will be guided in freely downloading the code, installing it on your computer, preparing input files, and happily using the code, producing results and graphs, and interpreting data and observations. This unit includes tutorials and exercises with solutions provided. You will then be able to check your capabilities and ensure that you are truly mastering SolveCAD. Now, it's time to undertake the trip, starting with the theoretical foundation of equilibrium thermodynamics in Unit 1. See you there.